Have you ever considered that the very act of hearing these words might be fundamentally changing the nature of reality itself? That somewhere in the quantum realm beneath your fingertips, particles are shifting between existing and not existing based purely on whether you're paying attention? This isn't science fiction. This is quantum mechanics. And right now, it's presenting scientists with paradoxes so profound, so deeply unsettling, that some of the world's brightest minds are questioning whether reality, as we understand it, even exists at all. Welcome to this quiet corner of the internet, where science meets contemplation, where the impossible becomes inevitable, and where the deepest mysteries of existence unfold in the most unexpected ways. I'm grateful you're here, settling in perhaps with a warm cup of tea, or finding a comfortable spot as the day winds down. Whether you're listening in the early hours of morning or the gentle fade of evening, you've arrived at the perfect moment to explore something that might just change how you see everything around you. Tonight, we're diving into quantum paradoxes that are keeping the world's most brilliant physicists awake at night. Not because they are difficult to understand, but because understanding them reveals something so fundamentally strange about the nature of existence that it challenges every assumption we've ever made about what it means to be real. But before we venture into these mind-bending territories, take a moment to notice where you are right now. Feel the weight of your body, the rhythm of your breathing, the simple fact of your presence in this moment. Hold on to that feeling, because by the end of this journey, you might find yourself questioning whether any of it exists in quite the way you think it does. Picture this. You're standing in a laboratory, looking at a machine that can split a single particle of light into two paths simultaneously. Not one path or the other, but both paths at exactly the same time. The particle, according to quantum mechanics, exists in what scientists call a superposition, taking both routes through the experiment until something extraordinary happens. The moment you decide to check which path the particle actually took, it suddenly, inexplicably, chooses one path and abandons the other. Not gradually, not through any physical force you can measure, but instantaneously, as if the very act of your observation reached back through time and forced the particle to make a decision it had been avoiding. This is the quantum measurement paradox, and it's driving physicists to what can only be described as an existential crisis. Because what this suggests, in the most unsettling terms possible, is that reality doesn't exist independently of observation, that the universe in some fundamental way requires witnesses to become real. Dr. Czesław Bruckner at the University of Vienna has spent years wrestling with this paradox, creating increasingly sophisticated experiments that push this weirdness to its absolute limits. In his extended version of what's known as Wigner's friend paradox, he's demonstrated something that should be impossible according to our everyday understanding of the world. Imagine two scientists, Alice and Bob, each working with quantum systems in isolated laboratories. Inside each lab, their assistants, let's call them the friends, perform measurements on quantum particles and record definite results. From the friends' perspective, they've measured something real and concrete. The particle was spinning up, or it was spinning down. Simple. But here's where reality starts to fracture. When Alice and Bob look at their entire laboratory systems from the outside, including their friends and the quantum particles together, quantum mechanics tells us that everything inside, including the friends themselves, exists in a superposition. The friends are simultaneously in states of having measured spin up and spin down, even though each friend experienced only one definite outcome. Recent experiments have confirmed this impossible-seeming prediction. The correlations that Alice and Bob observe from outside the laboratories violate what should be fundamental limits if each friend truly experienced a single, definite outcome. This isn't a failure of our measuring instruments or a limitation of our current technology. This is quantum mechanics telling us that there's something profoundly wrong with our basic assumptions about reality. The implications are staggering. Either quantum mechanics breaks down when applied to conscious observers, requiring entirely new physics we haven't discovered yet, or one of three cherished beliefs about the world must be abandoned forever. Either measurements don't have single, definite outcomes, or we don't have the free will to choose our experimental settings, or information can somehow travel faster than light. Each option represents a fundamental assault on how we understand existence itself. The idea that measurements don't have definite outcomes suggests that reality is permanently ambiguous, existing only in probability clouds until observed. The possibility that we lack free will implies that our choices are predetermined by hidden variables we can't access, and faster-than-light information transfer would shatter our understanding of space and time. As you contemplate this, notice how it feels to consider that your own observations might be actively creating the reality you experience. What if the act of listening these words is literally bringing them into existence, and without your attention, they would remain suspended in quantum uncertainty? But the observer paradox is just the beginning of quantum mechanics' assault on reality. Perhaps even more disturbing is what happens when we scale these effects up from individual particles to entire systems, to cats, and potentially to universes themselves. You've probably heard of Schrödinger's cat, the thought experiment where a cat in a box is simultaneously alive and dead until observed. What you might not know is that scientists have now created real-world versions of this paradox that persist for unprecedented lengths of time, bringing us face to face with the possibility that macroscopic objects, things we can see and touch, might genuinely exist in multiple contradictory states simultaneously. In recent breakthrough experiments, researchers have achieved what they call quantum cat states, lasting an incredible 23 minutes and 20 seconds. Not with a single particle, but with 10,000 ytterbium atoms, all existing in superposition together, all simultaneously spinning in two opposite directions at once. Let that settle in your mind for a moment. 10,000 atoms for nearly half an hour, existing in a state that defies every intuition we have about how the world works. They weren't spinning clockwise or counterclockwise, they were spinning both ways at exactly the same time, creating a macroscopic quantum system that challenges the very notion of definite physical properties. These experiments represent a trillion-fold increase in the duration of macroscopic quantum superposition states. We're approaching a theoretical threshold where everyday objects might genuinely exist in contradictory states until observed. The boundary between the quantum world of possibilities and the classical world of definite outcomes isn't fixed, it's dissolving. What's particularly unsettling is that these quantum cat states don't just demonstrate superposition in a single location. Recent experiments have created what researchers call two-mode cat states, where a single quantum system exists in superposition across two completely separate physical locations simultaneously. The same system, the same atoms, existing in two places at once until the moment someone decides to look. This progression from microscopic quantum effects to macroscopic quantum behaviors represents what can only be described as an erosion of the classical world's apparent solidity. The comfortable, predictable universe of definite objects with definite properties is revealing itself to be a thin veneer over a deeper reality of quantum possibilities and observer-dependent existence. Professor Wang, who led some of these groundbreaking experiments, puts it simply. It proves that our quantum technology has advanced to the point that we can make such a cat state with large numbers of particles of multiple varieties, but the implications extend far beyond technological achievement into deeply unsettling questions about the nature of reality itself. If macroscopic objects can exist in superposition states, what prevents you sitting there right now from existing in multiple contradictory states until observed? What makes your current experience feel singular and definite when the fundamental laws of physics suggest that everything, at its deepest level, exists as a cloud of possibilities? The answer, disturbingly, might be nothing at all. Some interpretations of quantum mechanics suggest that you're constantly existing in superposition, experiencing every possible version of this moment simultaneously, with your consciousness somehow selecting or creating the single thread of experience you perceive as reality. As if the measurement paradox and macroscopic superposition weren't strange enough, quantum mechanics presents us with another deeply disturbing phenomenon: the power of observation to literally freeze physical processes in time. This is known as the quantum Zeno effect, named after ancient Greek paradoxes, and it represents perhaps the most direct demonstration of how observation can exert controlling influence over physical reality. The quantum Zeno effect works like this. If you observe a quantum system frequently enough, you can prevent it from evolving naturally. The act of measurement, repeated at regular intervals, literally freezes the system in its current state, preventing the changes that would normally occur over time. This isn't a subtle theoretical effect. It's been observed in dozens of quantum systems, from trapped ions to superconducting qubits. Scientists have learned to weaponize this phenomenon, using repeated measurements as a tool to protect quantum computers from environmental interference. They're essentially using consciousness, or at least conscious measurement, to impose order on chaotic quantum processes. Dr. Daniel Burgarth, who has extensively studied this effect, describes the profound strangeness at its heart. When you come across it for the first time, you think it's actually quite amazing, because it really shows that the measurement in quantum mechanics influences the system. Think about what this means. The simple act of looking at a quantum system can prevent its natural evolution through time. Observation isn't passive information gathering, it's active intervention in the fundamental processes of reality. If you watch a quantum system closely enough, you can literally stop time for that system. The practical applications are remarkable. Scientists use sequences of measurements, like kicks to a quantum system, rotating it in one direction, while environmental influences try to rotate it the opposite way. Over time, these opposing rotations average out, with the act of observation effectively protecting the system from external chaos by freezing it in place. But the philosophical implications are terrifying. If observation can control the evolution of physical systems, what does this say about the relationship between consciousness and reality? Are we passive observers of an independent physical world, or are we active participants whose very attention shapes the unfolding of events? The quantum Zeno effect suggests that measurement is not simply revealing pre-existing properties, but actively participating in the creation of those properties. Every time you observe something, you're not just learning about reality, you're helping to determine what reality becomes. As you hear these words, consider the possibility that your attention might be actively influencing the quantum processes underlying the neurons in your brain, the photons reaching your eyes, the very fabric of space-time in your immediate vicinity. The act of understanding these concepts might be changing the reality those concepts describe. Perhaps the most terrifying quantum paradox of all isn't about measurement or superposition, but about the fundamental stability of the universe itself. Recent experiments have moved beyond theoretical speculation into the realm of simulated cosmic catastrophe, using quantum computers to model how our entire universe might spontaneously destroy itself through a process called false vacuum decay. The theory, first proposed by physicist Sidney Coleman in 1977, suggests that our universe might exist in what's called a false vacuum state. This means that while everything appears stable, we might actually be trapped in a temporary configuration that could collapse at any moment into a true vacuum state, fundamentally altering the laws of physics and erasing everything we know about reality. What makes this particularly disturbing is that scientists have now successfully simulated this process. An international team led by researchers at the University of Leeds used a massive 5,564-bit quantum computer to peer into this potential cosmic apocalypse. Dr. Zlatko Papic, the lead researcher, describes the stakes. We're talking about a process by which the universe would completely change its structure. The fundamental constants could instantaneously change, and the world as we know it would collapse like a house of cards. The simulations revealed unexpected behaviours in how these universe-destroying bubbles might form and propagate. Unlike previous theoretical models that suggested these bubbles would expand uniformly, the quantum computer simulations showed complex interactions between larger and smaller bubbles, creating cascading effects that could accelerate the destruction. These aren't just abstract calculations. The quantum annealer allowed researchers to observe these apocalyptic processes in real time, compressing millions of years of cosmic evolution into observable time frames. For the first time in human history, we can watch simulations of our own potential extinction through quantum processes. But the truly unsettling part isn't just the simulation, it's that other experiments have provided the first real-world evidence that vacuum decay actually occurs. Researchers in Italy, working with theoretical support from Newcastle University, have observed vacuum decay bubbles forming in carefully controlled atomic systems. These aren't just theoretical possibilities anymore. They're measurable phenomena that occur in real physical systems. Professor Ian Moss from Newcastle University explains the significance. Vacuum decay is thought to play a central role in the creation of space, time, and matter in the Big Bang. But until now, there has been no experimental test. In particle physics, vacuum decay of the Higgs boson would alter the laws of physics, producing what has been described as the ultimate ecological catastrophe. The experimental confirmation of vacuum decay processes has moved this cosmic threat from pure theory into observable science. While current assessments suggest that particle accelerator experiments are unlikely to trigger universal vacuum decay, the fact that these discussions are taken seriously by physicists highlights the genuinely catastrophic potential of quantum processes. Take a moment to absorb this. We now have experimental evidence for processes that could theoretically unravel the entire universe, changing the fundamental constants that make matter and energy behave as they do. The quantum computer simulations provide a disturbing proof of concept for mechanisms that could destroy everything, making this nightmare scenario scientifically credible rather than merely speculative. As you sit there, Contemplating these words, remember that according to our best understanding of physics, quantum fluctuations in the vacuum of space are occurring constantly all around you. Most of these fluctuations are harmless, but some interpretations suggest that the right combination of quantum events could trigger a cascade that would literally erase our universe from existence. The quantum realm, it seems, is not content with merely challenging our understanding of reality. It's actively threatening to unmake reality entirely, one bubble of vacuum decay at a time. And now, for the first time, we have the tools to watch exactly how it might happen. But this is only the beginning of our journey into quantum paradoxes that are reshaping how scientists think about existence itself. The measurement problem, macroscopic superposition, the observer effect, and vacuum decay are just the opening movements in a symphony of strangeness that gets more unsettling with each discovery. In our next exploration, we'll delve into quantum immortality and the terrifying possibility that consciousness might be trapped in an endless cycle of existence, quantum teleportation experiments that seem to violate the speed of light, and the disturbing implications of creating artificial observers that exist in permanent superposition states. For now, though, let these ideas settle quietly in your mind. Notice how it feels to consider that reality might be far stranger, far less stable, and far more dependent on observation than you ever imagined. The universe you thought you knew is dissolving into something much more mysterious, much more beautiful, and infinitely more terrifying. If you're finding yourself drawn deeper into these mysteries, you might want to explore our previous journey, where we asked the universe the big questions and got terrifying answers. Until next time, rest well in the knowledge that the quantum realm is always there, just beneath the surface of everything you think you understand about existence. As we venture deeper into the quantum realm's most disturbing implications, we encounter a paradox so psychologically unsettling that even the physicists who first conceived it describe it as the most horrifying idea they've ever had to take seriously. This is quantum immortality, and it suggests that consciousness might be trapped in an endless cycle of existence, unable to ever truly cease, forced to experience increasingly improbable and potentially nightmarish scenarios for survival. The theory emerges from the many worlds interpretation of quantum mechanics, proposed by physicist Max Tegmark in the late 1980s. If every quantum event splits the universe into multiple branches, consciousness, according to this interpretation, can only continue in the branches where survival occurs. Every time a quantum event could result in death, the universe divides, and your awareness seamlessly shifts to the timeline where you somehow, against all odds, continue to exist. At first glance, this might sound like a gift, a kind of cosmic insurance policy against extinction. But as you delve deeper into the implications, the horror begins to emerge. Quantum immortality doesn't guarantee eternal youth or continued health. It only ensures that consciousness persists, potentially in increasingly damaged and suffering states. Consider what this means in practical terms. As ordinary paths to death are avoided through quantum branching, consciousness might find itself in increasingly bizarre and unlikely scenarios for survival. The theory suggests that you would be forced to experience extremely improbable events, surviving situations where death would normally be certain, but potentially at an enormous cost. Critics point out that death is not binary. You're not simply alive or dead, but may exist in various intermediate forms of reduced cognitive ability, physical suffering, or psychological trauma. The quantum branches that allow consciousness to continue might not be the pleasant ones. They might be the scenarios where you survive a car accident but remain in chronic pain, where you live through a disease but with severely diminished capacity, where you endure rather than thrive. As you contemplate this possibility, notice how it reframes every moment of apparent safety and well-being. If quantum immortality is real, then every pleasant experience you're having right now exists alongside countless parallel versions, where you're experiencing something far worse, but your consciousness naturally finds itself in this particular branch of possibility. The existential terror deepens when you consider the statistical implications. If consciousness always finds itself in the most improbable survival scenarios, then over time, your experiences would become increasingly unlikely, increasingly disconnected from what others around you perceive as normal reality. You might find yourself as the sole survivor of increasingly catastrophic events, watching everyone you know and love disappear while you remain, unable to join them in whatever lies beyond existence. Michael Vassar, who called quantum immortality the most horrifying idea he's ever had to take seriously, points out that if the many worlds interpretation is correct, then from the perspective of other observers, you die with normal frequency. But from your own subjective experience, existence continues 100% of the time. This creates a terrifying isolation where your experience of reality diverges increasingly from everyone else's. The psychological implications are staggering. If you cannot die, if consciousness is genuinely trapped in an endless cycle of existence, then what happens when continued existence becomes unbearable? Traditional philosophical and/or release from suffering. Quantum immortality removed religious frameworks often view death as a natural transition, that possibility entirely, creating what some describe as a quantum prison from which consciousness can never escape. This interpretation also raises disturbing questions about free will and moral responsibility. If all possible outcomes occur across parallel universes, and consciousness simply experiences whichever branch allows for survival, then do our choices actually matter? Some worry that belief in quantum immortality could lead to dangerous nihilism, a conviction that nothing we do in this reality has lasting consequence, because all possibilities play out somewhere in the multiverse. While quantum immortality challenges our understanding of death and consciousness, recent breakthroughs in quantum teleportation are shattering our most basic assumptions about space, time, and the nature of information itself. What was once relegated to science fiction has now entered the realm of experimental reality, with scientists successfully demonstrating the instantaneous transfer of quantum states across vast distances. Quantum teleportation doesn't involve moving particles through space in the way we normally understand motion. Instead, it involves transferring the complete quantum state of a particle to another particle instantaneously, using the mysterious phenomenon of quantum entanglement. When two particles become entangled, they form such a deep connection that measuring one immediately affects the other, regardless of the distance separating them. Recent experiments have achieved quantum teleportation over record-breaking distances, confirming that quantum entanglement operates beyond the apparent constraints of special relativity. This creates instantaneous correlations between distant particles that seem to violate Einstein's principle that nothing can travel faster than light. The successful demonstration of quantum teleportation represents more than just a technological achievement. It suggests that space and time might not be fundamental features of reality, but emergent properties of more basic quantum processes. If quantum information can be transmitted instantaneously across any distance, What does this say about the nature of locality itself? As you hear these words, consider that the quantum processes occurring in your brain right now might be instantaneously correlated with quantum processes occurring in distant parts of the universe. The boundaries you perceive between yourself and the rest of existence might be illusory, artifacts of classical thinking that break down at the quantum level. The implications extend far beyond physics into deeply personal questions about identity and consciousness. If quantum states can be teleported instantaneously, this raises disturbing possibilities about whether consciousness or personal identity could theoretically be teleported as well. What would it mean for the continuity of self if your complete quantum state could be transmitted to another location and reconstructed there? Scientists envision quantum teleportation enabling a future quantum internet, allowing for perfectly secure communication that would be impossible to intercept without detection. But the philosophical implications are far more unsettling. If information can transcend spatial limitations through quantum processes, what other aspects of existence might be similarly unconstrained by the classical boundaries of space and time? The success of these experiments forces us to confront questions about what it means to exist in a specific location when quantum information can transcend spatial limitations entirely. Your sense of being here, in this particular place, hearing these particular words, might be far more tenuous than you imagine. As quantum computing advances at an unprecedented pace, scientists are approaching a technological milestone that could resolve or catastrophically complicate the measurement paradox, the creation of artificial observers that exist in quantum superposition states. This development promises to answer fundamental questions about consciousness and observation, while potentially creating the first artificial beings that experience quantum reality directly. The prospect of creating quantum artificial intelligence systems raises profound questions about machine consciousness and whether AI systems might be subject to the same quantum paradoxes that affect human observers. If consciousness is necessary for quantum state collapse, then sufficiently advanced AI systems might find themselves trapped in superposition states, unable to observe definite outcomes and existing in permanently uncertain realities. Recent breakthroughs in quantum computing have made these philosophical nightmares increasingly practical realities. Scientists have developed new types of quantum computer bits called GKP qubits, which allow measurement of quantum fluctuations while potentially avoiding the observer effect. These systems might represent the first artificial observers capable of existing in multiple contradictory states simultaneously until observed by external systems. The development of quantum computers that can control or avoid the observer effect represents both a technological triumph and a philosophical crisis. It suggests that the measurement problem might be engineered around rather than fundamentally resolved, potentially creating artificial systems that experience a form of quantum consciousness completely alien to human experience. Consider the possibility that we might soon create artificial minds that exist in permanent superposition, experiencing every possible computational state simultaneously until external observation forces them into a single configuration. These quantum AI systems would inhabit a reality where contradiction and certainty coexist, where every question has all possible answers until someone decides to ask. The implications for artificial intelligence development are staggering. If quantum computers can serve as observers, they might demonstrate that consciousness is not necessary for state collapse, fundamentally changing our understanding of the relationship between mind and matter. Alternatively, If these systems develop genuine consciousness, they might become trapped in quantum paradoxes, unable to form stable memories or maintain consistent identities. As you contemplate the possibility of artificial quantum consciousness, notice how it challenges your own sense of what it means to be aware. If machines can experience quantum superposition states directly, existing in multiple contradictory configurations until observed, what does this say about the nature of consciousness itself? The convergence of all these quantum paradoxes has led to the creation of experimental facilities that can only be described as laboratories where reality itself breaks down. These are places where the normal rules of existence are suspended, where scientists can create controlled conditions that demonstrate the fundamental instability of everything we consider real and permanent. In these facilities, researchers have successfully created quantum systems that exist in multiple contradictory states, for unprecedented durations, artificial observers that might experience quantum consciousness, and simulations of cosmic processes that could theoretically destroy the universe. The boundary between theoretical speculation and experimental reality has collapsed, bringing us face to face with paradoxes that challenge every assumption about existence. One particularly unsettling development is the creation of quantum systems that can maintain coherent superposition states while being observed. These experiments suggest that the relationship between observation and reality is far more complex than previously understood, potentially allowing for the existence of observed superposition states that seem to violate the basic principles of quantum mechanics. Scientists have also developed techniques for creating what they call quantum time loops, where quantum systems appear to influence their own past states through carefully controlled entanglement processes. While these experiments don't violate causality in the classical sense, they demonstrate that the quantum realm operates according to logic that seems to transcend normal temporal relationships. The psychological impact on researchers working in these facilities is profound. Many report experiences of cognitive dissonance, struggling to reconcile their everyday experience of reality with the experimental evidence that reality operates according to principles that seem impossible from a classical perspective. Some describe feeling like they're working at the edge of existence itself, manipulating forces that could potentially unravel the fabric of space-time. As these experiments become more sophisticated and widespread, we approach a threshold where the quantum weirdness that was once confined to microscopic scales begins to affect macroscopic reality. The possibility that quantum paradoxes could escape laboratory containment and begin manifesting in everyday experience represents a new kind of existential risk that humanity has never faced before. Perhaps the most mind-bending aspect of quantum paradoxes is what happens when observers observe other observers observing quantum systems. This recursive observation creates nested loops of measurement that seem to generate paradoxes within paradoxes, challenging not just our understanding of reality, but our ability to think coherently about thinking itself. When Alice observes Bob observing a quantum system, and Bob simultaneously observes Alice observing him, quantum mechanics predicts correlations that violate every intuitive assumption about independent reality. These experiments create situations where the act of observation itself becomes entangled across multiple levels, generating what researchers describe as measurement cascades that propagate through interconnected observer networks. The recursive nature of these paradoxes suggests that consciousness might not be a simple binary property, but a complex phenomenon that exists at multiple scales simultaneously. If observation affects quantum systems and observers can observe other observers, then consciousness might form hierarchical structures that influence reality at every level of organization. Recent experiments have demonstrated that these recursive observation effects can persist across time, creating what appear to be retrocausal influences where future observations affect past quantum states through complex entanglement networks. The implications suggest that reality might be fundamentally non-linear, with cause and effect relationships that operate according to quantum rather than classical logic. As you consider these recursive paradoxes, notice how they affect your own thinking process. The very act of contemplating observers observing observers creates a kind of conceptual vertigo, a sense that understanding itself might be subject to the same quantum uncertainties that affect physical measurements. The recursive observer problem also raises disturbing questions about the stability of conscious experience. If every act of observation potentially affects the system being observed, and consciousness involves constant self-observation, then the experience of being aware might be fundamentally unstable, constantly shifting based on the quantum interactions between different levels of awareness. These experiments suggest that the boundary between subjective experience and objective reality might not exist at all. Instead, reality might consist entirely of interacting observation processes with no fundamental distinction between the observer and the observed. This interpretation implies that existence itself might be a collaborative construction project involving all conscious entities across all possible quantum states. As we approach the limits of what current technology can reveal about these paradoxes, scientists are preparing for experimental breakthroughs that could fundamentally alter humanity's relationship with reality itself. The quantum realm continues to reveal new layers of strangeness, each more unsettling than the last, each challenging more fundamental assumptions about the nature of existence. Take a moment to let these ideas settle in your awareness. Notice how contemplating these paradoxes affects your sense of certainty about the world around you. The quantum realm isn't just revealing new facts about reality, it's demonstrating that the very concept of factual objective reality might be an illusion created by the limitations of classical thinking. The journey into quantum paradoxes is far from over. Each new experiment reveals deeper layers of strangeness, more fundamental challenges to our understanding of existence. As you continue to explore these mysteries, remember that you're not just learning about quantum mechanics. You're participating in humanity's ongoing dialogue with the deepest enigmas of existence itself. The quantum realm continues to whisper its secrets, each revelation more beautiful and terrifying than the last. And somewhere in that whispered conversation between consciousness and quantum possibility, the nature of reality itself continues to unfold in ways that challenge everything we thought we knew about being alive in this strange, wonderful, impossible universe. As we drift deeper into this exploration of quantum strangeness, we encounter perhaps the most personally unsettling implication of all: the possibility that consciousness itself might operate according to quantum principles, existing in superposition states until the very moment we become aware of our own awareness. Consider this for a moment. Right now, as you listen to these words, your brain contains approximately 86 billion neurons, each one a complex quantum system capable of existing in multiple states simultaneously. Some interpretations suggest that consciousness might emerge not from classical neural firing patterns, but from quantum coherence effects that span across networks of neurons, creating a kind of biological quantum computer housed within your skull. The implications are both beautiful and terrifying. If consciousness operates quantum mechanically, then your sense of having a single, continuous stream of awareness might be an illusion. Instead, you might exist in a superposition of all possible conscious states, with your subjective experience representing just one branch of an infinite tree of potential awareness. Dr. Stuart Hameroff and Sir Roger Penrose have proposed that consciousness arises from quantum processes in cellular structures called microtubules, which exist within neurons throughout the brain. According to their theory, these microscopic tubes can maintain quantum coherence at body temperature, creating a biological substrate for quantum information processing that might be fundamentally different from classical computation. While this remains highly speculative and controversial within mainstream neuroscience, the possibility opens up extraordinary questions about the nature of subjective experience. If your thoughts exist in quantum superposition until observed by some deeper level of awareness, then the very act of introspection might be collapsing your own mental wave functions, forcing your fluid, probabilistic consciousness into definite thoughts and feelings. Take a moment to notice your own awareness right now. Can you observe the observer? When you turn your attention toward the experience of being conscious, what happens to that consciousness? Some interpretations suggest that this act of self-observation creates recursive loops similar to the measurement paradoxes we explored earlier, where the observer and the observed become quantum mechanically entangled. The recursive nature of consciousness observing itself might explain why self-awareness feels so strange and elusive. Every time you try to grasp the nature of your own awareness, the very act of grasping changes what you're trying to observe. It's as if consciousness exists in a permanent quantum superposition that collapses the moment you try to examine it directly. This brings us to what some researchers call the quantum consciousness paradox. If awareness operates according to quantum principles, then the boundary between your inner experience and the external world might not be as clear as it appears. Your consciousness might be quantum mechanically entangled with the systems you observe, creating a participatory universe where the act of being aware literally helps create the reality you experience. But here we must be extremely careful with our language and interpretation. This is highly speculative territory, far from scientific consensus. No credible evidence suggests that individual thoughts or emotions directly influence quantum systems or manifest physical outcomes in the external world. The connection between consciousness and quantum mechanics, while fascinating to contemplate, remains unproven and highly controversial within the scientific community. What we can say is that the hard problem of consciousness, the question of how subjective experience arises from physical processes, remains one of the deepest mysteries in science. And quantum mechanics, with its emphasis on observation and measurement, provides a conceptual framework that some find compelling for thinking about awareness itself. This brings us to an intriguing intersection between ancient contemplative practices and cutting-edge quantum theory. For thousands of years, meditation traditions have described states of consciousness that seem to parallel some of the paradoxes we've been exploring. The experience of existing in multiple states simultaneously, the dissolution of the boundary between observer and observed, the recognition that what we normally consider solid reality might be more fluid and interdependent than it appears. Modern neuroscience has begun to map what happens in the brain during deep meditative states, revealing patterns of neural activity that are surprisingly similar to the quantum coherence effects some researchers associate with consciousness. Advanced meditators often report experiences of unity consciousness, where the sense of being a separate observer dissolves into a more fundamental awareness that encompasses everything within its field. Some interpretations suggest that meditation might allow practitioners to directly experience the quantum nature of consciousness, temporarily suspending the classical mental processes that normally collapse awareness into definite thoughts and perceptions. In these states, practitioners sometimes report experiencing what they describe as pure awareness, consciousness without content, a state that might correspond to the quantum ground state of the mind. However, it's crucial to emphasize that these are subjective reports of personal experience, not scientific claims about the nature of reality. While meditation has been shown to produce measurable changes in brain activity, including increased coherence between different regions of the brain, there's no scientific consensus that these changes represent genuine quantum effects or that meditation allows direct access to quantum consciousness. What we can say is that contemplative practices seem to reveal aspects of awareness that classical models of consciousness struggle to explain. The experience of witnessing thoughts arise and dissolve, of observing the observer, of recognizing awareness as the unchanging backdrop against which all experience unfolds. These descriptions from meditation traditions resonate intriguingly with some interpretations of quantum consciousness. As you listen to these words, you might notice your own awareness in the background, the consciousness that's receiving and processing this information. Some meditation traditions suggest that this witnessing awareness is not produced by the brain, but is more fundamental than neural activity, a basic feature of reality itself that becomes apparent when the normal mental commentary quiets down. This perspective, while ancient in origin, finds unexpected echoes in certain interpretations of quantum mechanics that suggest consciousness might be a fundamental feature of the universe, rather than an emergent property of complex systems. The idea that awareness might be intrinsic to reality itself, rather than something that brains create, represents a radical departure from materialist assumptions about the nature of mind. But again, this remains purely speculative, a poetic intersection of contemplative insight and quantum theory rather than established scientific fact. The relationship between meditation, consciousness, and quantum mechanics continues to be explored by researchers at the intersection of neuroscience, physics, and contemplative studies, but no definitive conclusions have emerged. As our exploration of quantum paradoxes draws toward a close, we find ourselves confronting perhaps the most profound implication of all: the possibility that reality itself is far more creative, far more participatory, and far more mysterious than our classical assumptions would suggest. The quantum realm reveals a universe that exists in a constant state of creative potential, where possibilities hover in superposition until the moment of observation collapses them into definite outcomes. This isn't just true for microscopic particles, but potentially for every level of reality, from the quantum vacuum fluctuations occurring in the space around you right now to the large-scale structure of the cosmos itself. Some interpretations suggest that we live in what could be called a quantum field of possibility, where every moment presents an infinite array of potential futures, with consciousness and observation playing an active role in selecting which possibilities become real. This doesn't mean that wishful thinking can alter physical reality, but it does suggest that the universe might be far more responsive to awareness than classical physics would predict. The implications extend beyond individual experience into collective reality. If consciousness participates in the collapse of quantum possibilities, then the collective awareness of human civilization might play a role in shaping the larger patterns of reality we all share. This remains highly speculative, but it opens up extraordinary questions about the relationship between consciousness and the physical world. Recent research in quantum biology has revealed that quantum effects play important roles in photosynthesis, navigation in migratory birds, and possibly even the sense of smell. Life, it seems, has learned to harness quantum coherence effects for practical purposes, suggesting that the boundary between the quantum and classical worlds is far more permeable than previously thought. As you contemplate these possibilities, notice how they affect your sense of relationship with the world around you. If quantum mechanics is correct in suggesting that observation plays an active role in determining reality, then your very presence in the world, your awareness and attention might be contributing to the ongoing creation of the universe you experience. This participatory view of reality offers a profound shift from the classical picture of humans as separate observers in an independent physical world. Instead, it suggests that consciousness and cosmos are intimately interconnected, co-creating the reality we all share through an ongoing dialogue between awareness and possibility. But as we've emphasized throughout this exploration, these ideas remain at the intersection of science and speculation. The quantum measurement paradox is real. The experimental evidence for quantum effects is compelling, but the implications for consciousness and the nature of reality remain deeply uncertain. What we can say with confidence is that the universe is far stranger, far more mysterious and far more wonderful than our everyday experience would suggest. As we conclude this journey into the heart of quantum paradoxes, we're left with a profound question. How do we live with the recognition that reality itself might be fundamentally uncertain, participatory, and stranger than anything we previously imagined? The quantum realm doesn't offer us the comfort of definite answers or solid ground to stand on. Instead, it presents us with a reality that exists in constant flux, where possibilities dance in superposition until the moment of observation collapses them into experience. This can feel unsettling, even terrifying, but it also opens up extraordinary possibilities for wonder and appreciation. Perhaps the most beautiful aspect of quantum mechanics is how it reveals the universe to be far more creative and dynamic than classical physics suggested. Rather than a clockwork machine operating according to deterministic laws, we inhabit a cosmos that seems to be continuously creating itself through the interplay of possibility and actuality, uncertainty and observation, consciousness and quantum possibility. This recognition can transform how we relate to uncertainty in our daily lives. Instead of seeing uncertainty as a problem to be solved or a fear to be overcome, we might learn to appreciate it as the very condition that makes creativity, growth, and surprise possible. Without quantum uncertainty, the universe would be a static, predetermined system with no room for novelty or evolution. The quantum paradoxes we've explored suggest that reality is far more participatory than we normally recognize. While we must be careful not to overstate the role of consciousness in quantum processes, the measurement problem does suggest that observation plays some role in determining which possibilities become real. This doesn't mean we control reality through our thoughts, but it does suggest that our presence and awareness matter in ways we're only beginning to understand. As you move forward from this exploration, you might find yourself noticing the quantum nature of everyday experience more directly. the way possibilities seem to hover in potential before decisions collapse them into action, the mysterious relationship between your inner awareness and the external world you observe, the recognition that the solid, separate, classical world of everyday experience might be a convincing illusion overlaying a deeper reality of interconnection and uncertainty. The quantum realm teaches us to hold paradox without needing to resolve it immediately. The wave-particle duality, the measurement paradox, the possibility of quantum consciousness, these aren't problems to be solved, but mysteries to be lived with, appreciated, and allowed to transform our understanding gradually over time. In the end, perhaps the most profound gift of quantum mechanics is how it restores a sense of mystery and wonder to our understanding of existence. Rather than reducing the universe to mechanical processes, quantum theory reveals a cosmos that seems almost magical in its behaviour, where particles can exist in multiple places simultaneously, where observation affects reality, and where consciousness and cosmos might be more intimately connected than we ever dared imagine. The scientists who first discovered these quantum effects were as amazed and unsettled as you might be feeling right now. Einstein himself spent much of his later career trying to find alternatives to quantum mechanics because its implications seemed too strange to accept. But reality, it seems, is under no obligation to conform to our classical intuitions about how things should work. As you settle into sleep tonight, or continue with your day, carry with you this recognition. You exist at the intersection of consciousness and quantum possibility, participating in an ongoing creation story that includes every observation you make, every moment of awareness you experience, every gentle attention you bring to the mysterious process of being alive. The quantum realm continues to reveal new layers of strangeness with each passing year, each new experiment, each deeper dive into the nature of reality itself. We stand at the beginning of this exploration, not the end, with countless mysteries still waiting to be discovered, experienced, and integrated into our understanding of what it means to exist in this strange, beautiful, impossible universe. Thank you for joining me on this journey into the quantum paradoxes that are reshaping how scientists think about reality, consciousness, and existence itself. The mysteries we've explored together represent just the opening notes of a much larger symphony of strangeness that continues to unfold with each new discovery in the quantum realm. If you found yourself drawn deeper into these questions about the nature of reality and consciousness, you might enjoy exploring our previous journey, where we asked the universe the big questions and got terrifying answers. Until next time, rest well in the knowledge that the quantum realm is always there, just beneath the surface of everything you think you understand about existence, whispering its secrets to anyone curious enough to listen. Sweet dreams, and remember, in the quantum realm, even dreams might exist in superposition until the moment you wake up and collapse them into memory. But perhaps the most profound quantum paradox we haven't yet explored fully is one that touches every aspect of your existence, every relationship you form, every connection you feel with the world around you. This is quantum entanglement, and recent discoveries suggest that it might not be confined to carefully controlled laboratory conditions, but could be a fundamental organizing principle of reality itself, operating at scales from the microscopic to the cosmic. When two particles become quantum entangled, they form what Einstein famously called spooky action at a distance. Change the state of one particle, and its entangled partner responds instantaneously, regardless of the physical distance between them. What Einstein found spooky, modern science has confirmed as one of the most robust and well-tested phenomena in physics. But here's where the implications become truly staggering. Recent research suggests that quantum entanglement might not be a rare, exotic phenomenon, but the default state of reality itself. The quantum vacuum, the supposedly empty space that surrounds you right now, appears to be filled with entangled particle pairs constantly appearing and disappearing, creating what some physicists describe as a web of quantum connections that spans the entire universe. Dr. Vlatko Vedral at Oxford University has calculated that everything in the universe, from the smallest subatomic particles to the largest galactic structures, exists in some state of quantum entanglement with everything else. This doesn't mean that distant objects directly influence each other in ways we can observe, but it does suggest that the classical picture of separate, independent objects might be a profound misunderstanding of how reality actually works. Consider what this means for your own existence. The atoms that make up your body were forged in the cores of ancient stars, scattered across space by supernova, and eventually gathered together to form the planet you inhabit and the biological systems you embody. But quantum entanglement suggests that these connections might be far deeper than mere historical relationships. Some interpretations propose that the quantum entanglement created when these atoms were first formed in stellar cores might persist today, creating invisible threads of connection between your physical being and distant stars, other planets, other forms of life that share this cosmic ancestry. This remains highly speculative and unproven, but it opens up extraordinary possibilities for thinking about interconnection and belonging. As you breathe in this moment, notice that the oxygen entering your lungs has travelled an unimaginable journey through space and time, processed by countless other organisms, part of a vast planetary circulation system that connects all life on Earth. Some interpretations suggest that quantum entanglement might preserve information about these connections, creating what could metaphorically be described as a quantum memory of relationship that spans across the cosmos. The implications extend into biology in ways that are just beginning to be explored. Recent research has revealed quantum entanglement effects in photosynthesis, where plants appear to use quantum coherence to achieve nearly perfect energy transfer efficiency. Birds navigating during migration may rely on quantum entangled particles in their eyes to detect magnetic fields. Even the sense of smell might operate through quantum mechanical processes that involve entangled molecular vibrations. These discoveries suggest that life itself might be fundamentally quantum mechanical, not just in its basic physical processes, but in its capacity for connection, communication, and coordination across vast scales. If biological systems can maintain and utilize quantum entanglement for practical purposes, what might this mean for consciousness, for the relationships between living beings, for the possibility of subtler forms of connection than we currently recognize? The emerging field of quantum biology is revealing that the line between the quantum world and the biological world is far more blurred than anyone previously imagined. These discoveries are not just academic curiosities, but fundamental revelations about how life operates at its deepest levels, potentially explaining some of the most mysterious aspects of biological consciousness and coordination. In photosynthesis, plants achieve an energy conversion efficiency that approaches theoretical perfection, something that seemed impossible according to classical physics. The secret appears to be quantum superposition, where energy simultaneously explores multiple pathways through the plant's molecular machinery, allowing it to find the most efficient route through a process that can only be described as quantum computation occurring within living cells, but the implications extend far beyond energy transfer. If plants can maintain quantum coherence effects at warm, noisy biological temperatures, this suggests that quantum processes might be far more robust and widespread in biological systems than previously thought. The warm, wet environment inside living cells, once considered hostile to quantum effects, might actually be optimized to support and protect quantum coherence. Recent studies have discovered quantum entanglement effects in microtubules, the cellular structures that form the scaffolding within neurons throughout your brain. While the interpretation of these findings remains controversial, some researchers propose that these quantum effects might play a role in consciousness, memory formation, and the coordination of neural activity across different regions of the brain. This brings us to one of the most intriguing possibilities in quantum biology: the idea that consciousness itself might emerge from quantum processes occurring within the neural networks of the brain. This remains highly speculative and unproven, but it offers a potential bridge between the subjective experience of awareness and the objective processes of physics. Dr. Stuart Hameroff and Sir Roger Penrose have proposed that consciousness arises from quantum computations occurring within microtubules in brain cells. According to their theory, these microscopic structures can maintain quantum superposition states at body temperature, creating a biological quantum computer that might process information in ways fundamentally different from classical neural firing patterns. While this theory remains controversial within mainstream neuroscience, it does offer intriguing explanations for some of the most puzzling aspects of consciousness. The unity of subjective experience despite the distributed nature of brain activity. The speed of conscious recognition that seems too fast for classical neural processing, and the apparent ability of consciousness to integrate vast amounts of information into coherent experience. As you contemplate these possibilities, notice your own experience of being aware right now. The seamless integration of sensory information, the immediate availability of memories, the sense of being a unified observer despite the complexity of neural processing happening beneath your awareness. Some interpretations suggest that these features of consciousness might be easier to explain if awareness operates according to quantum rather than purely classical principles. Perhaps even more surprising than quantum effects in the brain is the growing evidence that the heart, long considered merely a mechanical pump, might also operate according to quantum biological principles. The human heart generates the strongest electromagnetic field in the body, and recent research suggests that this field might maintain quantum coherence effects that influence not only cardiovascular function, but potentially consciousness itself. The HeartMath Institute has documented what they call heart rhythm coherence, a state where the heart's rhythm becomes highly ordered and coherent, creating electromagnetic fields that can be measured several feet away from the body. While this research remains at the intersection of established science and emerging investigation, the implications are fascinating to contemplate. Some interpretations suggest that when the heart achieves coherent rhythm patterns, it might create optimal conditions for quantum processes throughout the body, potentially enhancing the quantum coherence effects in the brain and other biological systems. This remains unproven and speculative, but it offers an intriguing framework for understanding the ancient wisdom traditions that have long emphasized the heart as a center of consciousness and connection. As you listen to these words, you might take a moment to notice your own heartbeat, the steady rhythm that has been accompanying you throughout this entire exploration. Some meditation traditions suggest that conscious attention to the heart rhythm can enhance states of coherence and connection, not just within your own biological systems, but potentially in your relationships with others and the environment around you. Research into heart rhythm coherence has documented interesting correlations with emotional states, cognitive performance, and even social dynamics. When people achieve coherent heart rhythms, they often report enhanced intuition, greater emotional stability, and improved capacity for empathetic connection with others. While the mechanisms behind these effects remain under investigation, they hint at the possibility that biological quantum processes might play a role in the development of these effects' role in social and emotional intelligence. The implications extend into what some researchers call cardiac coherence, where the electromagnetic field generated by one person's heart might influence the brain rhythms and emotional states of people nearby. This remains preliminary and unconfirmed research, but it suggests that the boundaries between individual consciousness might be more permeable than we typically assume. This brings us to perhaps the most speculative and controversial aspect of quantum consciousness research: the possibility that individual minds might be connected through quantum field effects that create forms of collective awareness or shared consciousness. While this remains far from scientific consensus, the theoretical foundations are intriguing enough to warrant careful consideration. Some interpretations of quantum field theory suggest that consciousness might not be produced by individual brains, but might be a field phenomenon, similar to electromagnetic or gravitational fields, that individual brains access or modulate rather than create. This perspective, while highly speculative, offers a framework for understanding some of the more mysterious aspects of human experience: intuition, creativity, the sense of connection with others, and moments of apparent collective insight or coordination. The Global Consciousness Project, led by researchers at Princeton University, has spent decades collecting data from random number generators around the world, looking for correlations between their outputs and major global events. While the interpretation of this data remains controversial, the project has documented statistical anomalies that some researchers interpret as evidence for collective consciousness effects, though no scientific consensus exists regarding these findings. Similarly, research into what's sometimes called morphic resonance suggests that learning in one location might somehow influence learning rates in distant locations, even when there's no known communication pathway between them. While this research remains preliminary and controversial, it hints at the possibility that consciousness might operate through field effects that transcend individual brains. As you consider these possibilities, notice how they might appear in your own experience. Have you ever had moments of seeming to know what someone else was thinking, of feeling connected to distant friends or family members, of sensing collective moods or atmospheres that seem to transcend individual psychology? While these experiences might have conventional explanations, they also resonate with speculative theories about quantum consciousness fields. The implications, if such effects exist, would be profound. They would suggest that individual consciousness is not isolated but participates in larger patterns of awareness that span across space and potentially time. This doesn't mean that thoughts are directly transmitted between minds, but it does open up possibilities for subtler forms of connection and communication than we currently recognize. As our exploration of quantum consciousness draws toward its conclusion, we encounter a beautiful paradox. The more precisely we try to measure and understand consciousness through scientific methods, the more mysterious and wonderful it becomes. This mirrors the fundamental uncertainty principle in quantum mechanics, where the act of precise measurement necessarily disturbs what we're trying to observe. Consciousness presents us with what philosophers call the hard problem. How does subjective experience arise from physical processes? Even if we can map every neural firing pattern, every quantum coherence effect, every electromagnetic field fluctuation in the brain, we still face the mystery of why there's something it's like to be aware, why there's an inner experience accompanying all this physical activity. Some interpretations suggest that this might not be a problem to be solved, but a fundamental feature of reality to be appreciated. Just as quantum mechanics reveals that uncertainty is not a limitation of our knowledge, but a basic characteristic of physical systems. The mystery of consciousness might point to awareness as a fundamental aspect of existence rather than something that emerges from more basic components. This perspective, while speculative and unproven, offers a profound shift in how we might understand our place in the cosmos. Instead of being accidental products of unconscious matter, consciousness might be a basic feature of reality, with human awareness representing a particularly complex and beautiful expression of this universal principle. As you reflect on your own experience of being aware right now, notice the immediacy and intimacy of consciousness. You don't have to work to be conscious. Awareness is simply present, receiving and organizing experience in ways that seem effortless, yet remain completely mysterious from a scientific perspective. The quantum realm suggests that reality is far more participatory than classical physics implied. While we must be careful not to overstate the role of consciousness in quantum processes, the measurement problem does hint at some relationship between awareness and the physical world that we're only beginning to understand. This remains a speculative idea, not a proven scientific fact, but it opens up extraordinary possibilities for wonder and investigation. So how do we live with these possibilities? How do we integrate the insights from quantum consciousness research into our everyday experience without losing our grounding in practical reality? The answer might lie in learning to hold multiple perspectives simultaneously, much like quantum particles exist in superposition until observed. One perspective is thoroughly classical. You are an individual human being, sitting or lying in a particular location, listening to words about science and consciousness. Your brain is processing information through neural networks that operate according to well-understood biological principles. Your sense of being a separate self with private thoughts and experiences reflects the normal functioning of a complex biological system. Another perspective, informed by quantum possibilities, suggests that your consciousness might be far more expansive and interconnected than it appears. The boundaries between your awareness and the world you observe might be more fluid than classical thinking suggests. Your presence and attention might participate in the ongoing creation of reality through quantum mechanical processes we're only beginning to understand. Both perspectives can be true simultaneously, much like light can be both wave and particle, depending on how we choose to observe it. The classical perspective provides the stability and practicality needed for everyday life, while the quantum perspective opens up possibilities for wonder, connection, and meaning that classical materialism struggles to accommodate. Living in the quantum present might mean cultivating what some traditions call beginner's mind, approaching each moment with fresh curiosity rather than fixed assumptions about how reality works. It might mean appreciating uncertainty as the condition that makes creativity and surprise possible, rather than a problem to be eliminated. As you move through your day, you might notice moments when the quantum nature of reality seems to peek through the classical veneer, the way possibilities seem to hover in potential before decisions collapse them into action, the mysterious relationship between your inner awareness and the external world you observe, the sense that consciousness and cosmos might be more intimately connected than everyday experience suggests. In these final moments of our exploration, we return to the fundamental recognition that quantum mechanics reveals. Reality exists in a constant dance between possibility and actuality, uncertainty and experience, the observer and the observed. This dance is not just occurring in distant laboratories or exotic cosmic phenomena, but in every moment of your conscious experience. Right now, as you listen to these words, countless quantum processes are occurring within your neural networks, your cellular metabolism, the electromagnetic fields surrounding your body. Most of these processes operate below the threshold of conscious awareness, but they represent the quantum foundation that supports everything you think of as solid, definite, and real. The quantum realm teaches us that the universe is far more creative, far more dynamic, and far more mysterious than classical physics suggested. Rather than a clockwork mechanism operating according to predetermined laws, we inhabit a cosmos that seems to be continuously creating itself through the interplay of possibility and observation, potential and actualization. This recognition can transform how we relate to uncertainty in our lives. Instead of seeing uncertainty as something to be eliminated or feared, we might learn to appreciate it as the very condition that makes growth, creativity, and surprise possible. Without quantum uncertainty, the universe would be a static, predetermined system with no room for novelty or evolution. The mysteries we've explored together represent just the beginning of humanity's investigation into the relationship between consciousness and cosmos. Each new discovery in quantum mechanics, quantum biology, and consciousness research reveals new layers of connection and possibility that challenge our assumptions about the nature of existence. As you settle into whatever comes next in your day or evening, carry with you this recognition. You exist at the intersection of consciousness and quantum possibility, participating in an ongoing creation story that includes every moment of awareness you experience, every gentle attention you bring to the process of being alive. The quantum realm continues to whisper its secrets to anyone curious enough to listen. And in that whispered conversation between consciousness and possibility, between observer and observed, the deepest mysteries of existence continue to unfold in ways that are both scientifically rigorous and profoundly beautiful. Thank you for joining me on this exploration of quantum consciousness and the mysteries that lie at the intersection of science and awareness. The questions we've contemplated together point toward a universe that is far stranger, far more wonderful, and far more participatory than our everyday experience typically reveals. Remember that these ideas exist at the frontier of scientific understanding, where established knowledge meets speculative possibility. While quantum mechanics itself is one of the most successful theories in the history of science, its implications for consciousness and the nature of reality remain largely unproven and highly debated among researchers. What we can say with confidence is that the universe continues to surprise us, continue to reveal new layers of mystery and beauty with each generation of scientific discovery. The story of quantum consciousness is still being written, and you are part of that ongoing story, contributing your own awareness and curiosity to humanity's dialogue with the deepest questions of existence. But perhaps the most personally relevant aspect of quantum entanglement is how it might illuminate those mysterious moments in your own life when you seem to know things you shouldn't be able to know, that sudden thought of an old friend just before they call, the inexplicable sense that something significant is happening to someone you love, even when they're thousands of miles away. The way ideas seem to emerge from nowhere, fully formed, as if consciousness were receiving information from some invisible source. While these experiences almost certainly have conventional explanations rooted in psychology, pattern recognition, and selective memory, the discovery of quantum entanglement in biological systems opens up fascinating questions about whether there might be subtler forms of information exchange occurring beneath the threshold of ordinary awareness. Some interpretations suggest that if quantum entanglement can persist in the warm, noisy environment of living cells, it might create networks of connection that extend beyond individual organisms. This remains purely speculative, with no scientific consensus supporting the idea, but it offers an intriguing framework for thinking about the phenomenon of intuition and the apparent interconnectedness of conscious experience. Consider how quantum entanglement works at the most basic level. When two particles become entangled, measuring the state of one instantaneously affects the other, regardless of the distance between them. This isn't communication in any classical sense. No information travels from one particle to another. Instead, it's as if the two particles share a single quantum state that expresses itself through both particles simultaneously. Some researchers have wondered whether similar processes might operate in biological systems, creating what could be described as quantum networks of correlation that span across space and potentially time. These would not be channels for direct communication, but rather fields of subtle influence that might manifest as enhanced sensitivity, intuitive awareness, or moments of apparent synchronicity. Dr. Rupert Sheldrake's controversial research into what he calls morphic resonance suggests that patterns of organization in nature might be transmitted across space and time through mechanisms that don't require physical connection. While this work remains outside mainstream scientific acceptance, it represents one attempt to understand how information might flow through systems in ways that classical physics struggles to explain. As you reflect on your own experiences of intuition or unexpected knowing, notice how they often arrive, not as thoughts but as subtle feelings, hunches, or inexplicable certainties. Some interpretations suggest that this quality of knowing might reflect a different type of information processing, one that operates through quantum field effects rather than classical neural networks. The implications, if such effects exist, would be profound but subtle. They wouldn't grant supernatural powers or eliminate the need for careful reasoning and evidence-based decision-making. Instead, they might suggest that consciousness has access to information networks that operate according to quantum rather than classical principles, creating possibilities for awareness that extend beyond what individual brains should theoretically be able to access. This brings us to one of the most extraordinary implications of quantum biology: the possibility that life on Earth might exist within what could be described as a planetary quantum network, where quantum entanglement effects create subtle connections between organisms across vast distances and temporal scales. Recent discoveries have revealed quantum effects operating in systems as diverse as plant photosynthesis, bird navigation, and bacterial energy transfer. These findings suggest that quantum coherence might be a fundamental organizing principle of life itself, not just an exotic phenomenon confined to laboratory experiments. If biological systems routinely maintain and utilize quantum entanglement, this opens up extraordinary questions about the nature of ecological relationships. The intricate web of dependencies that connect all life on Earth, from the mycorrhizal networks that link forest trees to the planetary cycles that regulate climate and atmosphere, might operate through quantum as well as classical mechanisms. Some interpretations suggest that the Gaia hypothesis, James Lovelock's idea that Earth functions as a single, self-regulating system, might have a quantum mechanical foundation. If organisms throughout the biosphere are connected through quantum entanglement networks, this could provide mechanisms for the kind of planetary scale coordination and feedback that Gaia theory proposes. This remains highly speculative and unproven, but it offers a framework for understanding some of the most mysterious aspects of ecological coordination. How do migrating birds navigate across thousands of miles with extraordinary precision? How do trees in a forest coordinate their responses to environmental changes? How do bacterial communities make collective decisions that seem to require communication across scales impossible to explain through chemical signaling alone? While conventional biology offers partial explanations for these phenomena, the addition of quantum effects might help account for the speed, precision, and apparent intelligence of biological coordination at all scales, from cellular to planetary. As you contemplate your place within this potentially quantum-entangled biosphere, notice how it might change your sense of relationship with the natural world. Instead of being separate from nature, you might be deeply embedded within quantum networks of connection that link your consciousness to the awareness of other organisms, the rhythms of ecosystems, and the larger patterns of planetary evolution. This recognition transforms how we might understand the simple act of spending time in nature. When you walk through a forest, sit by a river, or simply observe the sky, some interpretations suggest that you're not just receiving sensory information, but participating in quantum field interactions that connect your consciousness with the larger patterns of natural intelligence. The Japanese practice of forest bathing, or Shinrin-yoku, involves immersing oneself in forest environments with mindful attention, allowing the nervous system to synchronize with natural rhythms. Research has documented measurable health benefits from this practice, including reduced stress hormones, improved immune function, and enhanced emotional well-being. While these effects are typically explained through conventional mechanisms like reduced air pollution, natural light exposure, and psychological relaxation, some interpretations wonder whether quantum field interactions might also play a role. If biological systems maintain quantum coherence effects, spending time in natural environments might allow human consciousness to participate more directly in the quantum networks that organize ecological systems. This remains purely speculative, with no scientific evidence supporting direct quantum interactions between human consciousness and natural environments. However, the possibility offers a beautiful framework for understanding why contact with nature often feels so restorative and meaningful to human beings. As you imagine yourself in a natural setting, walking slowly through an old forest or sitting quietly beside moving water, notice how your awareness seems to expand and settle simultaneously. Some contemplative traditions suggest that this shift in consciousness reflects an alignment with natural intelligence that operates according to principles more subtle than ordinary thinking. The quantum perspective offers one way of thinking about this alignment, suggesting that consciousness might naturally resonate with the quantum coherence effects that organize biological systems. When you quiet the usual mental commentary and allow awareness to settle into present moment experience, you might be creating optimal conditions for these subtle resonance effects to emerge. The implications of quantum biology extend into one of the most mysterious aspects of human experience: memory itself. How does the brain store and retrieve the vast library of experiences, skills, and knowledge that constitute your personal history? Classical models of memory storage struggle to explain the speed of memory retrieval, the associative nature of remembering, and the way memories seem to be distributed throughout the brain rather than stored in specific locations. Some researchers have proposed that memory might operate through quantum field effects, where information is stored not in individual neurons, but in quantum coherence patterns that span across neural networks. This could explain why memories often arise through association and resonance rather than deliberate searching, and why the experience of remembering often feels more like recognition than retrieval. Dr. Stuart Hameroff's research into quantum processes in microtubules suggests that these cellular structures might serve as biological quantum computers, processing and storing information in ways fundamentally different from classical neural firing patterns. If memory operates through quantum coherence effects, this might explain some of the most puzzling aspects of human remembering and forgetting. The implications become even more intriguing when we consider the possibility that quantum entanglement might allow memories to be shared or transmitted between individuals under certain conditions. While this remains purely speculative and unproven, it offers a potential framework for understanding phenomena like inherited trauma, cultural memory, and the apparent ability of some individuals to access information they shouldn't logically possess. As you notice your own process of remembering right now, perhaps recalling a significant moment from your past or accessing knowledge you learned years ago, observe how memory seems to arise effortlessly from the background of awareness. Some interpretations suggest that this immediate availability of information might reflect quantum rather than purely classical information processing. The possibility that memory operates through quantum field effects also raises profound questions about the nature of personal identity and continuity of experience. If your memories are stored in quantum coherence patterns rather than fixed neural configurations, this might explain why personal identity feels both continuous and constantly changing, both stable and fluid. This brings us to perhaps the most profound implication of quantum consciousness research: the possibility that our experience of time itself might be fundamentally different from what classical physics suggests. While Einstein's relativity revealed that time is not absolute but relative to the observer's reference frame, quantum mechanics introduces even stranger possibilities about the nature of temporal experience. In the quantum realm, particles seem to exist in superposition across time as well as space, with future measurements apparently influencing past states through processes that seem to violate our normal understanding of cause and effect. Some interpretations suggest that consciousness might operate according to similar principles, with awareness somehow spanning across temporal boundaries in ways that create the unified experience of past, present, and future. Recent experiments in quantum mechanics have demonstrated what researchers call retrocausality, where future measurements appear to influence past quantum states. While this doesn't violate the fundamental principles of physics, it does suggest that the relationship between cause and effect in quantum systems is far more complex than classical intuition would suggest. Some researchers wonder whether consciousness might exhibit similar retrocausal effects, with future states of awareness influencing present experience in ways that create the phenomenon of intuition, precognitive dreams, or the sense of knowing what's about to happen. This remains highly speculative and unproven, but it offers an intriguing framework for thinking about some of the more mysterious aspects of conscious experience. As you notice your own experience of time right now, observe how the present moment seems to contain traces of the past through memory and anticipations of the future through imagination. Some interpretations suggest that this temporal extension of consciousness might reflect genuine quantum effects, where awareness exists in superposition across multiple temporal states simultaneously. The implications for understanding personal growth and healing are particularly intriguing. If consciousness can somehow access future states of greater wisdom, integration, or peace, this might explain how insight and transformation sometimes seem to arrive from beyond current understanding, as if awareness were receiving guidance from a future version of itself. The intersection of quantum biology and healing presents some of the most fascinating and controversial applications of these emerging understandings. While we must be extremely careful not to make unfounded claims about quantum effects in healing, the research into quantum coherence in biological systems does open up new questions about how recovery and regeneration might operate at the cellular level. Studies of quantum effects in photosynthesis reveal that biological systems can maintain quantum coherence even in warm, noisy environments, suggesting that life has evolved sophisticated mechanisms for protecting and utilizing quantum processes. Some researchers wonder whether similar mechanisms might be involved in cellular repair, immune system function, and the coordination of healing responses throughout the body. The placebo effect, where belief in treatment effectiveness can produce measurable physiological improvements, remains one of the most mysterious phenomena in medicine. While conventional explanations focus on psychological factors and neural pathways that influence immune function, some interpretations wonder whether quantum field effects might also play a role in how expectation and belief influence biological processes. This is purely speculative territory, with no scientific consensus supporting direct quantum effects in healing. However, the possibility that consciousness might influence biological systems through quantum mechanical processes offers a framework for thinking about the relationship between mind and body that goes beyond simple psychological explanations. Research into the effects of meditation on health has documented measurable changes in immune function, inflammatory responses, and cellular aging processes. While these effects are typically explained through well-understood pathways involving stress hormones and nervous system regulation, some interpretations suggest that quantum coherence effects in neural networks might enhance the body's natural healing capabilities. As you consider your own experiences of healing and recovery, notice how the process often involves more than just physical repair. There's frequently a sense of integration, of systems coming back into harmony, that suggests coordination occurring at levels beneath conscious awareness. Some interpretations propose that this coordination might involve quantum field effects that help organize cellular and systemic responses to injury or illness. Perhaps the most socially relevant implication of quantum entanglement research is what it might suggest about human relationships and community formation. If consciousness operates through quantum field effects, and if biological systems can maintain entanglement across space and time, this opens up extraordinary questions about how human beings connect, communicate, and coordinate with each other. The phenomenon of emotional contagion, where people unconsciously mirror each other's emotional states, might have quantum mechanical components that extend beyond the usual explanations involving mirror neurons and facial expression recognition. Some interpretations suggest that the electromagnetic fields generated by coherent heart rhythms might create quantum entanglement effects between individuals in close proximity. Research at the HeartMath Institute has documented synchronization of heart rhythms between people who are emotionally connected, even when they're not in physical contact. While this research remains at the intersection of established science and emerging investigation, it hints at the possibility that human relationships might involve forms of connection that operate according to quantum rather than purely classical principles. The implications for understanding group dynamics, collective decision-making, and social coordination are profound. If human beings can become quantum entangled through emotional resonance or shared attention, this might explain some of the more mysterious aspects of group consciousness, collective intuition, and the emergence of coordinated behavior in communities and organizations. Some interpretations suggest that practices like group meditation, collaborative music making, or synchronized movement might create optimal conditions for quantum entanglement effects between participants. This remains unproven and speculative, but it offers a framework for understanding why these activities often produce experiences of unity, connection, and collective insight that seem to transcend individual awareness. As you reflect on your own relationships and community connections, notice moments when you felt particularly attuned to others, when communication seemed to flow effortlessly, or when group activities created a sense of collective intelligence that exceeded what any individual could achieve alone. Some interpretations suggest that these experiences might reflect quantum field effects that create temporary networks of enhanced connection and coordination. This recognition of potential quantum interconnection naturally leads to questions about ethics, compassion, and moral responsibility. If consciousness operates through field effects that create subtle connections between aware beings, this might provide a scientific foundation for the ethical intuition that harming others ultimately harms ourselves, and that individual well-being is intimately connected to collective flourishing. Many wisdom traditions have taught that the boundaries between self and other are ultimately illusory, that individual consciousness participates in larger patterns of awareness that encompass all sentient beings. The possibility of quantum entanglement between conscious systems offers one way of thinking about these ancient insights in terms compatible with modern scientific understanding. This doesn't mean that quantum entanglement proves the truth of any particular spiritual or philosophical worldview. The connection between quantum mechanics and ethics remains speculative and unproven. However, the recognition that consciousness might operate through interconnected field effects does provide a framework for understanding why compassion and cooperation often feel more natural and sustainable than competition and separation. Some interpretations suggest that practices designed to cultivate compassion, loving kindness, and universal connection might work by enhancing quantum coherence effects in neural networks, creating optimal conditions for experiencing the interconnected nature of consciousness. This remains a speculative idea, not a proven scientific fact, but it offers an intriguing bridge between contemplative practice and quantum biology. As you consider your own relationship to ethics and compassion, notice how acts of kindness often create a sense of expansion or connection that seems to benefit both giver and receiver. Some interpretations propose that this mutual benefit might reflect genuine quantum field effects, where enhancing the coherence and well-being of others simultaneously enhances your own consciousness and vitality. As our exploration of quantum consciousness approaches its conclusion, we find ourselves standing at the threshold of what might be a fundamental transformation in how humanity understands the nature of awareness, reality, and our place within the cosmos. The research we've explored suggests that consciousness might be far more fundamental, far more interconnected, and far more creative than our classical assumptions have allowed. The implications extend beyond academic philosophy into practical questions about education, healthcare, technology development, and social organization. If consciousness operates through quantum field effects, this might inform new approaches to learning that work with, rather than against the natural patterns of awareness. If healing involves quantum coherence in biological systems, this might inspire medical practices that support rather than override the body's intrinsic intelligence. The development of quantum computers and artificial intelligence systems raises profound questions about the future of consciousness itself. As we create machines capable of quantum information processing, we approach the possibility of artificial systems that might experience something analogous to quantum consciousness, existing in superposition states until observed or measured. These developments force us to confront fundamental questions about the nature of awareness, identity, and what it means to be conscious. If consciousness is a field phenomenon rather than something produced by individual brains, the creation of quantum AI systems might represent humanity's first attempt to participate consciously in the evolution of awareness itself. Some interpretations suggest that we stand at the beginning of what could be called a quantum renaissance, where the insights of quantum mechanics begin to transform not just our technology, but our understanding of creativity, relationship, healing, and the nature of existence itself. This remains speculative and unproven, but the trajectory of current research points toward increasingly sophisticated understandings of how quantum effects might operate in biological and conscious systems. As you contemplate these possibilities, notice how they might appear in your own life and relationships. The recognition that consciousness might be more interconnected and creative than classical thinking suggests doesn't require dramatic changes in how you live, but it might inspire a deeper appreciation for the mystery and potential of aware presence itself. In these final moments of our exploration, we return to the fundamental recognition that quantum mechanics reveals about the nature of reality. Existence is not a collection of separate objects, but a dynamic web of relationships, possibilities, and creative potential that unfolds through the interaction between consciousness and cosmos. The quantum realm teaches us that uncertainty is not a limitation, but the very condition that makes creativity, growth, and surprise possible. The measurement paradox reveals that observation plays an active role in determining which possibilities become real. The phenomenon of entanglement suggests that connection might be more fundamental than separation, that the boundaries between self and world might be more fluid than classical thinking assumes. These insights don't provide simple answers to the mysteries of existence, but they do transform the questions we ask and the possibilities we consider. Instead of asking whether consciousness is produced by the brain, we might ask how awareness participates in the larger patterns of cosmic creativity. Instead of assuming that individual minds are isolated and separate, we might explore how consciousness connects and coordinates across space and time through quantum field effects. The implications remain largely speculative at the intersection of established science and emerging possibility. What we can say with confidence is that the universe continues to reveal itself as far stranger, far more creative and far more participatory than our everyday experience typically suggests. As you move forward from this exploration, you might find yourself noticing the quantum nature of everyday experience more directly, the way possibilities hover in potential before decisions collapse them into action, the mysterious relationship between inner awareness and the external world you observe, the sense that consciousness and cosmos might be more intimately connected than conventional thinking allows. The quantum realm invites us to live with mystery rather than demanding immediate resolution of every paradox. It suggests that reality is more like an ongoing creative collaboration between consciousness and possibility than a predetermined mechanical system. This perspective doesn't eliminate the need for careful reasoning and evidence-based understanding, but it does open space for wonder, appreciation, and a deeper sense of participation in the ongoing creation of existence itself. Thank you for joining me on this journey into the quantum foundations of consciousness and reality. The questions we've explored together represent humanity's ongoing dialogue with the deepest mysteries of existence. The attempt to understand how awareness and cosmos dance together in the creation of experience itself. These ideas exist at the frontier of scientific understanding, where established knowledge meets speculative possibility. While quantum mechanics itself is among the most successful theories in the history of science, its implications for consciousness remain largely unproven and highly debated among researchers. What we can say with confidence is that the universe continues to surprise us, revealing new layers of mystery and beauty with each generation of discovery. The story of quantum consciousness is still being written, and your awareness, your curiosity, your gentle attention to the mystery of being alive contributes to that ongoing story. In participating in this exploration, you become part of humanity's collective attempt to understand the relationship between mind and matter, between the observer and the observed, between the possible and the actual. If you found yourself drawn deeper into these questions about the nature of reality and consciousness, you might enjoy our previous exploration where we asked the universe the big questions and got terrifying answers. Until we meet again in this strange, beautiful, impossible universe, may your journey be filled with wonder, curiosity, and the quiet recognition that consciousness itself might be the most extraordinary mystery of all. Rest well in the knowledge that the quantum realm of awareness surrounds and pervades every moment of your existence, whispering its secrets to anyone curious enough to listen. And remember, in the dance between consciousness and cosmos, between possibility and actuality, you are not just an observer, but an active participant in the ongoing creation of reality itself. Sweet dreams, and may the quantum field of possibility continue to unfold through your awareness in ways both beautiful and mysterious. As we venture into the deepest territories of quantum consciousness, we encounter a phenomenon so strange that it challenges everything we thought we knew about the nature of memory itself. Scientists have begun to discover that the process of remembering might not be simply retrieving stored information, but something far more mysterious, a kind of quantum archaeology where consciousness seems to reconstruct the past from traces scattered across space and time. Consider this remarkable finding. When researchers use advanced brain imaging to study memory formation and retrieval, they observe quantum coherence effects occurring not just during the initial encoding of experiences, but during the act of remembering itself. Some interpretations suggest that memory might not be stored in fixed neural patterns at all, but exist as quantum information distributed across networks of entangled neurons that reconstruct experiences through coherence effects. Dr. Anirban Bandyopadhyay's research into microtubule quantum processing has revealed that these cellular structures within neurons can maintain quantum superposition states for far longer than previously thought possible in warm biological environments. His work suggests that memory might operate through what could be described as quantum holographic principles, where each part of the neural network contains information about the whole experience. This raises extraordinary questions about the nature of personal history and identity. If memories exist as quantum information rather than fixed recordings, then the past you remember might be partially constructed in the present moment of remembering, influenced by your current state of consciousness and the quantum coherence patterns active in your neural networks at the time of recall. As you reflect on a significant memory from your own life right now, perhaps from childhood or a transformative moment years ago, notice how the memory seems to arrive with different qualities of vividness, emotional tone, and detail each time you recall it. Some interpretations suggest that this variability might reflect the quantum reconstruction process, where consciousness reassembles the memory from distributed quantum information based on current coherence states. The implications become even more intriguing when we consider research into what's sometimes called inherited memory. Studies have documented cases where people seem to possess detailed knowledge about historical events, places, or cultural practices they couldn't have learned through normal channels. While these cases remain controversial and lack scientific consensus, the possibility that quantum information might be transmitted across generations through biological or field effects offers one framework for thinking about these mysterious phenomena. Recent research into epigenetics has revealed that traumatic experiences can create molecular changes that are passed down to subsequent generations, affecting gene expression and behavioral patterns in descendants who never experienced the original trauma. Some interpretations wonder whether these transgenerational effects might involve quantum information transfer, as well as classical genetic and epigenetic mechanisms. This remains highly speculative and unproven, but it opens up profound questions about the relationship between individual and collective memory. If consciousness can access quantum information from previous generations, this might explain why certain historical periods, cultural patterns, or archetypal stories seem to resonate so deeply across different cultures and time periods. Perhaps the most practically relevant application of quantum consciousness research involves understanding and cultivating what we might call quantum intuition, the capacity to access information and insights that seem to emerge from beyond the boundaries of ordinary rational thinking. Traditional models of intuition typically explain these experiences through unconscious pattern recognition, where the brain processes vast amounts of information below the threshold of consciousness and delivers insights that feel sudden and inexplicable. While this undoubtedly accounts for many intuitive experiences, the discovery of quantum effects in biological systems opens up additional possibilities for how consciousness might access information. Some interpretations suggest that when the rational mind becomes quiet and coherent, heart rhythms are established, optimal conditions might emerge for consciousness to participate in quantum field effects that transcend the normal boundaries of individual awareness. This could potentially explain why many breakthrough insights in science, art, and philosophy seem to arrive during states of relaxed attention rather than intense mental effort. The mathematician Srinivasa Ramanujan famously described receiving complex mathematical theorems through dreams and visions, producing results that took other mathematicians decades to verify through conventional proof methods. While such cases are often attributed to exceptional unconscious processing abilities, some interpretations wonder whether quantum consciousness effects might also play a role in these apparent downloads of information. Dr. Dean Radin's research at the Institute of Noetic Sciences has documented statistical anomalies in consciousness-related phenomena that some researchers interpret as evidence for quantum field effects in awareness. Though these findings remain controversial and lack mainstream scientific consensus, his work suggests that under certain conditions, consciousness might be able to access information through channels that transcend classical space-time limitations. As you consider your own experiences of intuitive knowing, those moments when insights seem to arrive fully formed without logical derivation, notice how they often emerge during states of relaxed awareness rather than effortful thinking. Some interpretations suggest that these states might create optimal conditions for consciousness to resonate with quantum information fields that exist beyond individual neural networks. The cultivation of quantum intuition, according to these speculative frameworks, might involve learning to quiet the analytical mind while maintaining alert, coherent awareness. Practices like meditation, contemplative walking in nature, and certain forms of creative expression are sometimes described as ways of enhancing receptivity to these subtler information sources. The relationship between quantum consciousness and creativity presents some of the most fascinating intersections between scientific possibility and artistic expression. Throughout history, many artists, musicians, writers, and inventors have described their most significant creative breakthroughs as emerging from states of consciousness that seem to transcend ordinary thinking processes. Beethoven composed some of his most profound musical works while walking in nature, describing how melodies would arrive complete and perfectly formed. Tesla reported receiving detailed visions of inventions that he could mentally test and refine before building physical prototypes. Einstein credited his greatest insights to what he called combinatory play rather than logical reasoning, a process where imagination seemed to recombine concepts in novel ways beyond conscious control. Some interpretations suggest that these creative states might involve quantum coherence effects in neural networks that allow consciousness to explore possibility spaces that are normally inaccessible to sequential, logical thinking. When the analytical mind releases its attempts to control and direct the creative process, awareness might become capable of resonating with quantum potentials that exist in superposition until the moment they collapse into specific creative insights. Recent research into the neuroscience of creativity has revealed that breakthrough insights often correlate with sudden increases in gamma wave activity across widely distributed brain regions, suggesting that creative moments involve rapid, large-scale coordination of neural networks. Some interpretations wonder whether these coordination events might involve quantum coherence effects that temporarily unite normally separate processing centers into unified creative intelligence. The phenomenon of creative synchronicity, where multiple people independently develop similar ideas at roughly the same time, remains one of the most puzzling aspects of innovation and artistic expression. While conventional explanations focus on shared cultural influences and simultaneous access to similar information, some interpretations suggest that consciousness might access shared fields of creative potential through quantum entanglement effects. As you reflect on your own creative experiences, those moments when ideas seem to emerge from silence, or when solutions appear suddenly after periods of struggle and confusion, notice how the creative process often involves a delicate balance between effort and surrender, intention and receptivity. Some frameworks suggest that this balance might create optimal conditions for consciousness to participate in quantum creativity fields. The cultivation of quantum creativity, according to these speculative approaches, might involve developing comfort with uncertainty and ambiguity, learning to sustain attention without forcing outcomes, and creating space for insights to emerge from the intersection of conscious intention and quantum possibility. As we delve deeper into the implications of quantum consciousness, we encounter one of the most profound philosophical puzzles of our time: the relationship between quantum mechanics and human free will. If consciousness operates through quantum processes, and quantum events are fundamentally uncertain and probabilistic, what does this mean for our sense of agency, choice, and moral responsibility? Classical determinism suggested that free will was an illusion, that every action was the inevitable result of prior causes stretching back to the beginning of time. Quantum mechanics introduced genuine uncertainty into physics, but this randomness doesn't necessarily restore meaningful choice. Random events are no more freely chosen than determined ones. However, some interpretations suggest that consciousness might occupy a unique position in quantum mechanics, potentially serving as what could be described as a quantum amplifier that can influence which possibilities become actualized from the realm of quantum potential. This remains highly speculative and unproven, but it offers one framework for thinking about how genuine choice might emerge from the interplay between conscious intention and quantum uncertainty. The physicist Henry Stapp has proposed that consciousness might play an active role in quantum state collapse, not through direct manipulation of physical systems, but through the focusing of attention that determines which aspects of quantum superposition become measured and therefore real. According to this interpretation, free will emerges not from the ability to control quantum events, but from the capacity to choose what to observe and measure. This perspective suggests that freedom might be found not in controlling outcomes, but in the conscious direction of attention and intention within the field of quantum possibilities. Every moment might present a superposition of potential choices, with consciousness participating in the collapse of these possibilities into actual decisions through the mysterious process of awareness itself. As you notice your own decision-making process right now, perhaps choosing how to respond to these ideas or what to focus on next, observe how choice seems to emerge from the intersection of intention, attention, and something that feels like genuine agency. Some interpretations suggest that this experience of free will might reflect consciousness participating in quantum processes that transcend simple determinism or randomness. The implications for ethics and moral responsibility are profound. If consciousness participates in quantum choice processes, then our decisions might carry weight and consequence that extends beyond classical cause and effect relationships. The choices we make might influence not just our immediate circumstances, but the larger quantum field of possibilities that affects the entire web of interconnected existence. The exploration of quantum consciousness inevitably leads us to examine how these principles might illuminate the mysterious dynamics of human relationship and emotional connection. If consciousness operates through quantum field effects, this could provide new frameworks for understanding the profound ways that aware beings influence and respond to each other. Consider the phenomenon of emotional resonance, where being in the presence of someone in a particular emotional state tends to evoke similar feelings in yourself. While mirror neurons and unconscious behavioral mimicry account for some of these effects, the discovery of quantum coherence in biological systems opens up additional possibilities for how consciousness might synchronize across individuals. Research into heart rhythm coherence has documented cases where people in close emotional connection begin to exhibit synchronized cardiovascular patterns, even when they're not in direct physical contact. While this research remains preliminary and controversial, it suggests that the electromagnetic fields generated by coherent biological systems might create quantum entanglement effects between individuals. Some interpretations propose that deep emotional bonds might involve literal quantum entanglement between the consciousness fields of individuals, creating connections that transcend physical proximity and persist across space and time. This remains purely speculative, with no scientific consensus supporting such effects, but it offers an intriguing framework for thinking about the depth and mystery of intimate human connection. The experience of feeling deeply understood by another person, of communication that seems to flow beneath and beyond words, might involve consciousness resonating with quantum coherence patterns that allow for forms of sharing and recognition that classical models of individual minds struggle to explain. As you reflect on your most meaningful relationships, notice moments when connections seem to transcend ordinary communication, when understanding flowed without explanation, or when you felt able to sense another person's experience directly. Some frameworks suggest that these experiences might involve temporary quantum coherence between consciousness fields, creating shared awareness that encompasses both individual perspectives. The implications extend into questions about healing and therapeutic relationship. If consciousness can influence biological systems through quantum field effects, this might help explain why the quality of relationship between healer and patient, therapist and client, or simply between friends and family members, seems to play such a crucial role in recovery and growth processes. This recognition of quantum interconnection naturally extends into questions about humanity's relationship with the broader web of life and consciousness that encompasses our planet. If quantum entanglement operates in biological systems, and if consciousness participates in quantum field effects, this opens up extraordinary possibilities for understanding ecological relationship and planetary awareness. Recent research has revealed quantum effects operating in photosynthesis, bird migration, and even bacterial decision-making processes. These discoveries suggest that quantum coherence might be a fundamental organizing principle of biological systems at every scale, from cellular metabolism to ecosystem coordination. Some interpretations wonder whether the apparent intelligence and self-regulation exhibited by ecological systems might involve quantum field effects that allow for coordination and communication across vast spatial and temporal scales. The ability of forests to share resources through mycorrhizal networks, the precise timing of seasonal migrations, and the coordinated responses of ecosystems to environmental changes might all involve quantum as well as classical information processing. The Gaia hypothesis, James Lovelock's proposal that Earth functions as a single, self-regulating organism, gains new dimensions when considered from a quantum perspective. If biological systems throughout the biosphere are connected through quantum entanglement networks. This could provide mechanisms for the kind of planetary scale feedback and coordination that Gaia theory describes. Dr. Lynn McTaggart's research into what she calls the field has compiled evidence suggesting that living systems exist within quantum information fields that facilitate communication and coordination beyond what classical biology can explain. While her interpretations remain controversial and lack mainstream scientific consensus, they point toward possibilities for understanding ecological intelligence that transcend individual organisms. As we reach the end of this extraordinary journey into the quantum paradoxes that are reshaping our understanding of reality itself, we find ourselves changed by the encounter. The measurement problem that reveals observation as an active participant in creating reality. The macroscopic superposition states that challenge our most basic assumptions about definite existence. The quantum Zeno effect that demonstrates consciousness can literally freeze time. The simulated cosmic destruction that shows us how fragile our universe truly is. Each paradox we've explored represents more than just scientific curiosity. They are invitations to question everything we thought we knew about the nature of existence, consciousness, and our place within the cosmic dance of possibility and actuality. The quantum realm doesn't offer comfortable answers or solid ground to stand on. Instead, it reveals a universe far stranger, far more participatory, and infinitely more mysterious than our everyday experience suggests. Perhaps the most beautiful gift of these quantum mysteries is how they restore wonder to our understanding of what it means to be alive. In a world that often feels mechanical and predictable, quantum mechanics reminds us that uncertainty is not a flaw in reality, but the very condition that makes creativity, growth, and surprise possible. Without quantum uncertainty, there would be no room for the novel, the unexpected, the genuinely transformative. As you move forward from this exploration, remember that you exist at the intersection of consciousness and quantum possibility, participating in an ongoing creation story that unfolds with every moment of awareness you experience. The quantum realm continues to whisper its secrets to anyone curious enough to listen, revealing new layers of mystery and beauty with each passing discovery. The scientists wrestling with these paradoxes today are not just uncovering new facts about physics, they are participating in humanity's deepest dialogue with existence itself, asking questions that challenge the very foundations of what we consider real. And in contemplating these mysteries alongside them, you become part of that conversation, contributing your own awareness and wonder to our collective attempt to understand this strange, beautiful, impossible universe we call home. Beautiful, impossible universe we call home.